So hello everyone and welcome back. It's been a long time since I made a video. So today I have compiled a few questions, like whatever questions I could get my hands on, from 28th Jan Shift 1 of JEE Mains 2025. 28th Jan Shift 1, and we'll be doing only physics questions. So according to people online, I've heard that this is one of the toughest shifts, especially for physics. So let's do. I have a few questions gathered, so let's try them. So the first one starts off easily. It's units and dimensions. So yeah, modulus of elasticity per unit torque. So we know that dimensions of modulus of elasticity is same as pressure, which is ml minus 1 t minus 2, and then for torque it's same as energy, so that is ml2 t minus 2. So the dimensions are this are going to be l minus 3 t0. I don't know why they have given b equal to 3 over here. I think it's supposed to be b equal to minus 3. So okay, anyway, still doesn't matter. The value of c is going to be 0. So yeah, we started off easily. Okay, this is an assertion reasoning type question. So assertion says, in a central field the work done is independent of the path chosen. Yes, that is indeed correct. And then for reason says, every force encountered in mechanics does not have an associated potential energy. Yes, even that is correct. Like we know that only conservative forces have a potential energy associated with them. So forces like gravitation and electrostatic force, they all have potential energy associated with them. Yes, but non-conservative forces like friction and viscous force, they do not have any p associated with them. So we can say that uh, this assertion is indeed correct, and the reason is also correct, but it does not explain. It does not explain the statement. So the correct answer is going to be second option. Right, let's move to the next question. This one seems like a good question. Let's try it. So initially you have a mass m over here at rest, and then finally you release it. So it's going to end up somewhere along this arc, and then it says the equilibrium length of the spring is r, and currently it is stretched to 2r. So when it is, so finally the spring reaches its equilibrium length, so it's going to be something like this. The spring is going to be, and this length is going to be r, and let's mark this as our center O, and then we'll make a line like this. By the properties of a circle, this also must be r and this also must be r. So now we can see that the triangle is an equilateral triangle, so all angles are 60 60 60 60. So I'm going to go to the next page so we can do it freely. It looks messy in that page, so I'll get a big diagram. So initially the spring is like this. I'm showing the initial spring in red, so this is the center. Now I'll use yellow to show the final state of the spring. Finally it's like this. This is the line I have drawn, and this is r, this is r, and the particle is over here, and it has a velocity, some v. They're asking us to find the value of this v. Alright, they're asking us to find the value of v. I see. Okay, this is a good question. I mean, if you get the idea how to do it, it's pretty much straightforward. So what we are going to do is, so what's happening over here? Here we can see that the particle has lost some gravitation potential energy, and also because the spring was originally extended, but now it is at its natural length, it has lost some of its spring potential energy. So now we need, initially the spring was at 2r, and it came to its natural length L naught and L. So what is the extension in this case? So extension in the spring is R. So the loss in spring potential energy is going to be 1 by 2 k r square. So let's keep this aside. P, delta P, and now we need to find out how much gravitational potential energy it has gained. So let me draw a perpendicular line to the original spring over here. So this is 30 and this is r. So yeah, this part is going to be the radius itself. Up to my O is going to be the radius, and now we want this part. What is this going to be? So let's this right over here. If you take the component of this radius onto this surface, is going to be r cos 60, r cos 60, which is r by 2. So total, so this thing is going to be r by 2. The total distance it has traveled downwards is going to be 3r by 2. So now let's do it. So gain in gravitational potential energy plus loss in spring potential energy is equal to gain in kinetic energy. Now let's put our equations. I'll do that in red again. So what's the gain in gravitational potential energy? 3 into mg and distance, yeah, mgr by 2. And what's the loss in spring energy? Going to be, we have already calculated it, 1 by 2 k r square, which is going to equal the kinetic energy of the object finally, 1 by 2 mv square. mv square, I'm running out of space over here. This is mv square. So solving for it, we get 3. We can multiply both sides with 2. We'll get 3 mgr plus kr square is equal to mv square. And now send the m this side. You'll get 3gr plus kr square by m is equal to v square. So finally, I don't know why I'm going from right to left, alright, but fine. We get the velocity as root of 3gr plus kr square by m. Now let's go to the options and see if our answer is matching. 3gr plus kr square plus m. Yeah, this is the answer. Now off to the next question. Okay, this is a center of mass based question, and they say the areal density varies with x. It varies with x. So as we can see, the areal density along the y-axis is constant. So the coordinate of our center of mass is going to be at y equal to b by 2. By basic symmetry we can say that. So we can eliminate option 4. We can eliminate option 4. So now we know that coordinate of center of mass is given by the x coordinate is given by integration of dm times x by integral of dm. Okay, now let's find a dm over here. So let me add a distance x from the origin. I will take a small thin strip of width dx at a distance x. Now what's going to be the mass of this small elementary part of our sheet? So it's going to be the areal density at that point. Areal density at that point is given by sigma naught x by ab. This is the dm is equal to into the area of this thin strip. So what's the thin strip? It's basically a rectangle. So the width of this rectangle is dx and the length of it is b. So finally we get dm as our b cancels over here, sigma naught x dx by a. This is dm. So let's calculate the denominator first. Integral of dm, which is going from 0 to, finally this coordinate is a, which start at x equal to 0 and end up at x equal to a. From 0 to a, this is going to be sigma naught x square by 2a from 0 to a, which is sigma naught a square by 2a, which is sigma naught a by 2. This is the denominator part. Now let's do the numerator. So we have dm is equal to sigma naught, let me see it again, sigma naught x dx by a, sigma naught x dx by a. So now we want the numerator. What's the numerator? The numerator is the integral of x dm. So let's multiply with x both sides. So if I multiply with x over here, it's going to become x squared. Now let's do the integrate on both sides. from 0 to, this is going to be 0 to a again. So we get this integral as, this integral is going to be 0 to a again, sigma naught by a x cube by 3 from 0 to a, which is going to be sigma naught a cube by 3a, this sigma naught a square by 3. This is the numerator, and now we have to do the numerator we have just solved in the other page, and this is the denominator which we got. The denominator is sigma naught a by 2. So x coordinate of center of mass is 1 naught a square by 3 divided by sigma naught a by 2, which is going to be sigma naught a square by 3 1 naught a by 2. Finally we end up with x coordinate of the center of mass is 2a by 3. If you simplify this, you'll get 2a by 3. Now let us check the options. Yes, so our y coordinate is b by 2 and x coordinate is 2a by 3, which we have just solved for. So I would say option 1 is the correct answer. Okay, again statement type questions. I have noticed that in 2025 they have been giving more of these type of questions where you need to do some critical thinking. Okay. Viscosity is measured by a ball having radius r. Consider the following statements. Graph between terminal velocity v and radius will be a parabola. Okay, now let us write the relation between the radius and terminal velocity. So we know that terminal velocity is given by 2 by 9 g into radius square into density of the ball minus density of the medium by coefficient of viscosity. As we can see over here, the terms that are marking in blue are all constant. G is constant, and this is for a given medium, so viscosity is constant, the ball is the same, and the medium is the same. So all these are constant. 2 by 9 is of course a constant. So we can rewrite this as Vt is equal to, all the constants I'll multiply and denoted by k into r square. And if we graph this, we can see that the graph is of the form y equal to kx square, which is indeed a parabola. Let me draw it a bit better. It touches the origin, yeah, kind of like this. So I'd say statement 1. So let's note down statement A is correct. Now B. Terminal velocities of different diameter balls are constant for a given liquid. Again, now let us look at the equation again. Different diameter balls means the radius is varying, and for a given liquid implies that these two are constant, these are constant, this is constant. So we can see that the velocity is of course going to change. So I'd say statement B is wrong. And now C. Measurement of terminal velocity is dependent on the temperature. Yes. For a given ball, like, okay, consider a medium. We can, it's a fact that the coefficient of viscosity always varies as a function of temperature. I don't know the function, but yeah, it does vary as a function of temperature. So with varying temperature, our eta is going to vary, and then in turn our v is also going to vary. So it is dependent on temperature. C, I'd say, is correct. The experiment can be utilized to assess the density of the liquid. Okay, let me write it again. 2 by 9 r square rho of the ball minus of the liquid by neat. So for if we are doing this, we can measure the terminal velocity, we can measure the radius, we know the details of the liquid, so eventually we know the details of the ball, so eventually we can solve for the density of the liquid. So D is also in fact correct. If the balls are dropped with some initial velocity, the value of eta will change. Okay, so we should know that you should know that eta just depends, it's a property of the fluid, depends on fluid, so it does not have anything to do with the initial velocity of the ball. So I'd say E is also wrong. So what we can say, A is correct, C is correct, and D is correct. So according to them, option 3 is the answer to this question. Okay, another statement type question. Okay, surface tension arises due to the extra energy of molecules at the interior compared to the molecules at the surface. No, we know that it's quite the opposite. It is due to the fact that the molecules at the surface have more energy than the interior. So statement A is wrong. Okay, as temperature of liquid rises, the coefficient of viscosity increases. No, again I'd say this is wrong, because as the temperature increases, there are, you know, it is easier for a, like, okay, it is easier for an object to move through the thing. So if temperature increases, it decreases. So I'd say B is also wrong. So A is wrong, B is wrong. Looking at the option, it's going to be C, D, E, but okay, fine. As temperature of gas increases, coefficient of viscosity increases. Hmm. Alright, let's come back. I'm back. So okay, if the temperature of the gas increases, the coefficient of viscosity increases. For a gas, that is true. So I'd say option C is correct. Now let's looking at the option. Yeah, it's just this one. So onset of turbulence is determined by Reynolds number. Yes, Reynolds number is a measure of turbulence. If the Reynolds number for fluid is more than a given value, it is turbulent. If it is less than that, it is considered laminar flow. So D is correct. In a steady flow, two streamlines never intersect. Yes, that is also correct. Option 1 is correct in this question. After the next question. Okay, Carnot engine. This is deleted according to the portion given by them, but I don't know why they keep doing this. Okay, we'll just do it. So for engine for E, the temperatures are, the main engine is 273 come 473. So efficiency 1 2, as we are using the notation given by them, is 1 minus 273 by 473. Taking the LCM, and we get 200 by 473. This is eta 1, sorry, eta 1 2. And for E1, the temperatures are 473 Kelvin and 373 Kelvin. So the efficiency of engine 1 is going to be 1 by 373 by 473, which is again 100 by 473. This is efficiency 1. Efficiency 2, okay, the engine runs between 273 Kelvin and 373 Kelvin. So efficiency is going to be 1 minus 273 by 373, that is 100 by 373. So now we have gotten our values. Let's verify the options. So yeah, what can we say if you combine two engines? So what can you see over here? The main engine is a combination of engine 1 and 2, but it does not work for the efficiencies. You cannot do for the efficiency, like efficiency 1 is not equal to efficiency 1 plus efficiency 2. It doesn't work that way. So I'd say, like, due to the laws of thermodynamics, there will be some energy loss. There's no, what does the law say? There can be no perfect engine. So looking at the question, I will think that the efficiency of the main engine should be less than the efficient product of efficiencies of 1 and 2. Let me just verify that we have the numerical values. So product of individual efficiencies is, what's it, n1 and 2 is, let me verify this option, because no way this can be right and no way this can be right. So let me verify this. N1 plus N2 is 100 into 1 by 373 plus 1 by 473. That is okay. Let me go to the next page for this. Oh, my bad. Okay, I'll just clear the ink from this. So let me, yeah, 1 plus e2 is 100 into 1 by 373 plus 1 by 473, which is, what's 373 plus 473? It's going to be 7 no 854. So 100 into 854 by 373 into 473. So let me take 2 here. So it's going to be 200 into, what's it, 427 by 373 into 473. Now what do we have here? What is our efficiency of the main engine? Our eta 1 2 is going to be, sorry, this is eta 1 and eta 2. Eta 1 2 is going to be 200 by 473, as we have calculated before. So now from this, in the sum of efficiencies, we can see that this part 200 by 473 is nothing but my eta 1 2, and the number which is it's being multiplied with, the number in yellow, it's greater than 1. So we can say from this that the actual efficiency is something lesser than the sum of individual efficiencies. So option 4 is the correct answer for this question. Off to our next question. I don't know why they keep doing that, giving deleted topics. So what is this? Okay, relation between mean squared velocity, RMS velocity, and the temperature. What do we know? Vrms is given by root 3 RT by molecular weight of the gas. So this, for a given gas, this is constant. So Vrms is proportional to root T. So it's going to be a parabola turned 90 degrees. So the graph is going to be something like, something of this sort. So looking at it, yeah, option 3 is the most appropriate answer for this question. Okay, this is a good question. It needs a bit of thinking. So there are 3 infinitely long wires with charge density lambda along x, y and z axis. What they are asking, the equation of an equipotential surface. Okay, ignore 3 wires. Let's start with a single wire. If you have a single wire and you're at distance r from it, and you're over here, what's the electric field over there? The electric field is going to be, and okay, assume its charge density is lambda, 2k lambda by r. This is the electric field. So what do we know? What is potential? So potential is basically minus integral of E dot dr. So potential is going to be minus integral of 2 lambda k by r dr, which is minus 2k lambda ln r and plus some integration constant. If we have been given values, we can substitute and eliminate the constant, but find the constant. But here, okay, we'll just assume it as c. All right, this is, and what is r in this case? It just denotes us the distance from the wire. Now let's take the 3D coordinate system. I'll do it in a proper way. We have 3 wires. I'll draw them all in different colors so that we can see it properly. This is one wire, this is another wire, x-axis, this is y-axis, this is x-axis. Now the z wire. We have the 3 wires, 3D space, infinitely long. So now let us go to our basics. Take a point, take a random point in the coordinate system, x comma y comma z. So let us calculate the potential due to it from the first wire, V due to the x wire. What's it going to be? Okay, now let's go back to our coordinate geometry. If you have a given point like this, what's the distance of this point from the x-axis? So distance from the x-axis is going to be nothing but y square plus z square under root, and distance from the y-axis is going to be x square plus z square under root. Distance from z axis is going to be y square plus x square under root. So yeah, this is what we have basically. So our potential due to this wire, it is 2k lambda ln distance due to distance from this wire, which is basically distance from the x-axis, ln root y square plus z square plus some v naught. I'll take that as a constant, and vy is going to be 2k, this is k, 2k lambda ln distance from y-axis, which is going to be x square plus z square under root plus again v v1, let it be whatever. Vz is going to be 2k lambda ln under root x square plus y square, alright, plus v2. Now let us simplify. What is an equipotential surface mean? So the total potential at that surface is equal to some constant value. So we have equipotential surface 2k lambda ln, the root is there, it's going to come out as 1 by 2, and it'll cancel out this 2, so I'll just write this k ln x square y square plus z square plus k lambda ln x square plus z square plus k lambda ln x square plus y square plus I'll sum up all these constant as some c plus c is equal to some other constant value c naught. So I'll send it this there, it will become c minus c minus c naught minus c. I'll denote it by c dash. So what do we have? And divide. So we have, I need more space for this question, and now let's divide again with a constant, divide with k lambda on both sides. So ln y square plus z square plus ln x square plus z square plus ln x square plus y square. You're dividing a constant with a constant, it will become another constant again. I'll write it with a c. And now use the property of ln over here. Use the property of ln. If two natural logarithms are being added, it is, you can product them. So what's this going to be? Ln x square plus y square times y square plus z square times x square plus z square is equal to c. Now power it with e on both sides, and you'll be left with x square plus y square times y, okay, z square plus y square times x square plus z square is equal to some constant value c dash dash. So looking at this, I'd say option 3 is correct. So this question, once you get the thought process, it's easy, it's nothing much. But yeah, this is much higher than your average mains level questions, almost at advanced level. But yeah, this is how to do it. Okay, a particle of mass m is fastened to one end of a massless string having equilibrium length L, and okay, horizontally frictional plane and at rest. Uniform electric field is switched on, and the speed when it crosses the x-axis, the speed of the particle is. So yeah, how do you think the movement of this string is going to be? The electric force is going to act this way, and then tension is going to act this way, and the component of electric force is going to cancel out the tension, and there will be a perpendicular component, it will provide torque. So this is how it's going to be. It's going to trace a circular path. I'll use a darker color over here. Darker color, yeah, I'll use this. Is going to trace a path like this, a circular path with radius L. So now we have to find out the velocity, the downward velocity of this when it crosses the x-axis, when it's over here. So why does it gain velocity? First thing, because it is gaining potential, its potential is going to change. It is moving along the electric field. So what is the change in potential? It's just going to be, the change in potential is going to be E into L, because it's constant electric, E into not L, E into delta L over here, sorry, wrong variable, E into delta L over here, and this is delta L. I'll use it as delta L. Yeah. So into delta L. What is delta L over here? Now we have to come back to trigonometry. This whole thing is a circle, so this whole thing is going to be a length of L, and this part, this part is going to be L cos 60. So this part is going to be L by 2. So this part is going to be L by 2. The whole thing is L, and this is a delta L. So we can see that delta L is going to be L by 2 over here. So our delta L is L by 2. So what's the potential difference? Potential difference is going to be E into L by 2. And what's the change in potential energy? The potential difference times the charge of it. So delta E, this is, okay, delta PE is going to be delta V into Q. This is going to be E L by 2 into Q, and all of this is getting converted into kinetic energy. So finally we can solve for the kinetic energy. V is equal to under root of E Q L by M. Now let's go back to the options. Yeah, option 2 is the correct answer. Alright, next question. Okay, this is a graph based question. So what does it say? Finally, this thing, after a long time, more or less is going to be this value, and even this thing, more or less it will be the same value. So we can see that the final, okay, this is for C2 and this is for C1. We can see that the final charges on C2 is great, Q2 is greater than Q1. That's what we can take from this graph. Alright, so what is Q? In a capacitor we know that Q is capacitance times the voltage, and as both capacitors are connected in parallel to a battery, the voltage across them is the same in both cases. So we can say that Q in this case is proportional to the capacitance. Alright, so as Q2 is more than Q1, we can say that C2 is greater than C1. This is what we can say. And now look at the energies. What's the energy of a capacitor? 1 by 2 C into V square. Again here the voltages are constant, so again energy is also proportional to the capacitance over here. Same for both, so energy is proportional to capacitance. So as C2 is greater than C1, so U2, E2 or U2, they are using U2, U2 is more than U1. So from this, option 4 is correct. Oh, this is okay. Finally, after giving all such tough questions, they decide to throw in an easy question. Alright, these 2 points are the same potential, they are the same. These 2 points are electrically the same potential, so this circuit can be read on, okay, A, B. So you have point A over here, so it's like this. All are in parallel basically, that's what they do. So you have R by 3, R by 3, R by 3. As all are equal resistances, you divide by 3 over here, and R equivalent is going to be R by 9. Option 1 is correct. Okay, this is also a very good question in my mind. So this might take some time, it's a long question. So they are telling you have a long thin conducting wire, and at a distance A from the wire, a charged particle is released along the direction of the current. So this particle is released with V0 along the direction of the current. Okay. Due to the magnetic force, the particle gets attracted, of course. Now let us use the left hand rule and find the direction of the force at the initially when it was released. So we have magnetic field due to it. Use our right hand rule. We can see that the magnetic field over here is into the plane. So and then the current is upwards. So initially this thing is going to have a force this way, it's going to pull it this way, but this is a centripetal force. So after a second, the particle travels something like this. But now, yeah, it's not exactly a circular path. When will it be a circular path? when the when the magnetic field is constant all over, it's going to trace a circular path. But now we can see that because it's a wire, the magnetic field will vary with the distance inversely. So the field is changing as it comes closer to the wire. So it won't be a circular path, it's going to be a weird curve of some sort, not a circle. And eventually its velocity will reverse downwards. Initially we gave it a velocity like this, eventually it will reverse downwards. And now they are asking at what distance is this going to happen. This is probably one of the best questions in the paper. This one and the electrostatics, electro equipotential one, I like those questions a lot. So now let us do this question. So I will clear this. Okay, so now you have a wire. Now take the particle at a random distance x and assume the magnetic field here is uh, B. So I'm taking this coordinate system x and y. So the particle here has some velocity vx and some velocity vy. So its velocity vector is going to be vx I cap plus vy j cap, and the magnetic field is going to be, let me assume it as B, and it's going to be minus b k cap. Just use the thumb rule, minus b k cap. So what do we know? Force on a moving charge in a magnetic field is given by q times velocity vector cross the magnetic field vector. At this point, okay, now let us cross these. We have I cap, j cap, k cap, and vx, vy, and 0, 0, 0, b. I'll take it as b. So what do we have? Forces, all this times q times this determinant, q times I cap into vb, vy, b I cap minus j cap into vxb. This is the force, and now this is j cap. Okay, I forgot to write that. Now what are they asking? They are asking the time, the distance when the y component of the velocity reverses, it becomes the negative of itself. So let us find the term which has the y component of the velocity and use it that way. So even our f bar is going to be what? M a I cap ax I cap plus m a y j cap. This is going to be q vy b I cap minus q vx, okay, I ran out of space, vxb j cap. So this term right over here has vy over here, which is going to be useful to us. Vx currently we don't have anything to do with that, it's not related to our question much. So let us deal with these terms, the circle terms. So we have m ax I cap is equal to, what do we have there, q vy b, q vy b I cap. Okay, so I will write a as v dv by dx, m a vy dv by dvy by dx. Notice that I'm writing dx because the velocity is changing as it moves along the x-axis. So I'm writing dx v is equal to q vy into what's the magnetic, okay, I'll leave it as b here for ease of calculation. Why did I write I? This term is nothing but our a. So I'm going to cancel these two terms. And now what do we have here? M d vy is equal to q b dx. This is what we have. So what's our B? What's the magnetic field due to a wire at a distance x from it? So mdvy is equal to q into mu naught I by 2 pi x into dx. This is the thing. Now let us integrate this on both sides. Now we'll see what the limits are going to be. So here what? Initially the velocity, the lower limit, initially it had a velocity of a v in the positive y direction. Initially v naught in the positive y, but finally what do we want it to be? Minus, we want it to be v naught in the negative y, so I'll put minus v naught here. And initially it is at a distance a from the wire, and the final distance x is what we have to find. Now doing the integral, we get minus m minus minus 2 mv naught is equal to q mu naught I by 2 pi, all are constant, and you have integral of dx by x from x to a. It's going to what's the integral of 1 by x? It's ln x, and limits are x to a, so ln x minus ln a, which will be x ln x by a. This is what we have. Now let's do some rearranging. We get minus 4 pi m v naught by q mu naught I is equal to ln x by a. This is what you have. Now let me e power on both sides. So we have e power minus 4 pi v naught by q mu naught I is equal to x by a. Send the a this way. You have a e power minus 4 pi mv naught by q mu naught I is equal to x. So this is what we have calculated the x as. Now let us look at the options, if our options match. Yes, option A seems to match our answer, and that is the answer. So I really enjoyed doing this question. This involves proper thinking. Even this is more or less or touching advanced level. It's of course more difficult than your average mains level. Alright, next question. Okay, we have moved on to an easy question right over here. So we have two prisms over here, P1, the thin prisms over here, angle is 4 degrees, and we have another prism of in refractive index 1.72, and we want to get dispersion without any deviation. So whatever deviation is due to this prism is to be nullified by the second prism. So we have to arrange them in this way. I'll assume this to be A and P2. What's the formula for deviation due to a thin prism? It's mu minus 1 into angle of prism. This is for thin prisms. So numerically, if these two are equal, mu1 a1, if these two are equal, mu2 minus 1 a2, we will get dispersion without any deviation. Okay. So let us plug in the values. So for the first one, it's 1.54 minus 1. So 1.54 minus 1 into 4 is equal to 1.72 minus 1 into a. So 0.54 into 4 is equal to 0.72 times a, and this is 0.18 times 3, 0.18 times 4, and then 4 cancelled. We get a is equal to 3 degrees as our answer. Okay, this is again, I will make the diagram of this on the next page so that we can get a clear view. So there's a hemisphere like this filled with some liquid of some refractive index mu. You have a liquid, and there's a coin over here. Is that a coin? I think it looks. There's some object at the bottom of it, and it has a radius r. I'll mark the object in another color. There's an object over here, and I am seeing from here. This is my eye. I'm seeing it from here. So I want to see it from here. So what they're asking, the minimum refractive index of this liquid filled in the hemisphere. So what's the extreme condition, like the bare minimum condition, so that I can see this thing. I will do this in yellow again. I'll do this in blue. So it should go like this, and then it should have it should, have critical incidence. It should go perpendicular to the normal. Only then, that's the bare minimum condition for which I can see the thing. So now all we need to do is find the angles and apply Snell's law. Let's find the angles. So as this is a hemisphere, this is also going to be r. So yeah, tan, this is 45 degrees, and with the normal, this is the normal over here. I'll make it in blue so that we can see clearly. This is the normal. So our incident ray is making 45 degrees with the normal. This is a transversal over here, so this too will be 45 degrees, and then it is exiting perpendicular to the normal. Now it's basic Snell's law. So mu times sine 45 should be equal to refractive index of air. We'll take it as 1 into, and sine angle of refraction. Angle of refraction is just 90 degrees again, which is again 1. So what do we have? Mu by root 2 is equal to 1. So we have mu equal to 2, root 2, sorry. So everyone just looks at this question and just gets scared, but in reality it's just nothing. Look at this, just not even 2 lines of calculations. So once you get the basic idea, it's very easy. Mu is root 2. Okay, just a minute. Yes, I'm back. Yeah. Okay, we have Young's double slit experiment. Initially it's performed with a wavelength of 600 meters, and the 10th bright fringe is at a distance of 10 millimeters from the central maximum. Okay, this is 10th fringe. It's at 10 mm from the central maximum. So what is fringe width? Number of fringes by total distance from the central maxima. What is it? Fringe width is going to be number of total distance by number of fringes. Yeah, 1 mm is the current fringe width with 600 meters. We know that fringe width is also proportional to the wavelength of light in this case. So initially our fringe width is 1 mm for lambda is equal to 600 nanometers, but now we have made lambda is equal to 660 nanometers. So as beta, as our fringe width is proportional to lambda, because we have increased the wavelength by 10%, our fringe width will also increase by 10%. So the new fringe width is going to be 1.1 millimeters with the new light with 600 millimeters. So now they are asking what's the location of the 10th bright fringe. So the fringe width is 1.1 millimeters times 10. This is 11 mm. So the answer for this question is 11 millimeters. I don't know why I wrote millimeters, but okay. Next question. Okay, proton has same energy as a photon of wavelength lambda. If the proton is moving at a non-relativistic speed, ratio of its de Broglie wavelength to the wavelength of the proton is. Okay, they gave that hc by lambda, which is energy of the photon, is equal to 1 by 2 mp. M is m. Okay, in this case I'll just write mp as m because there is no other mass. We'll just use this. M into v square is equal to E. Alright, now what do we have? So we know that de Broglie wavelength is given by h by momentum of the particle. Now let us find the momentum of the proton. So we have the kinetic energy. What's the relation between kinetic energy and momentum of a particle? So we know that p squared by 2m is equal to kinetic energy. So we get p is equal to root of 2 into mass into ke. So here momentum of the proton is going to be root 2me. So lambda of proton de Broglie wavelength is going to be h by root 2me. And now let's take for the photon, hc by lambda is E. So we have lambda is equal to hc by E, a lambda photon. Now what are they asking? Ratio of de Broglie wavelength of proton to, so we want lambda of proton by lambda of photon, which is h by root 2 me divided by divided by h by hc by E. I've run out of space again. hc by, this is C, so we get the ratio as 1 by C E by root 2 me. Now just taking E into the square root, we get 1 by C root E by 2m mass of proton, okay, mp. So option 4 is the correct answer. Okay, choose the correct nuclear process from the given below. This is, I think, the last question, I believe, and this is a pretty straightforward theory based question. A neutron will break down to give a proton plus an electron plus antineutrino. This is the reaction. Or else a neutron will give proton plus a positron and neutrino. So looking at the options, we can see option this is correct.